Hi everyone. So this is our final project for the course EE701. So the purpose of this project is to monitor the parameters of the Davis Hall, of its first floor, the second floor, and the third floor. So basically we are trying to monitor the temperature readings, the humidity readings, and also for the first floor, we would like to monitor the luminosity reading. And we also have a PIR sensor in vicinity of our smart board, which is on the first floor, to make sure that our unit stays protected, or if there is any movement in its vicinity, we get a notification on our cloud that there is a motion. So that's the fundamental idea. We are using different kinds of sensors and trying to understand how different parameters they vary as we go above the floors.
Okay. So for the hardware, on the first floor, we are using Arduino Maker Wi-Fi's, and we have PIR sensor here. We have a DHT22 temperature and humidity sensor here, and we have a photoresistor over here as well. And then on the second and third floors, we have two ESP32s that also have temperature and humidity sensors, which you will see shortly. So here we have the ESP32 that's on the second floor. It has a temperature and humidity sensor attached to it, and it's reading those values from the sensor, and it is sending those values to the ESP32 that's on the third floor through ESP Now. Here we have the ESP32 that's on the third floor. It also has a temperature and humidity sensor here, and it both receives data from the ESP32 on the second floor below, and also it's connected to the internet and sends its own sensor data and the sensor data of the ESP32 on the floor below, both to Adafruit IO. So it utilizes ESP Now to reduce the amount of devices on the network, which increases bandwidth and improves performance.
So the cloud platform that we are using, which will actually be acting as our MQTT broker, is Adafruit IO. So you can see that we have two groups set up here, MQTT test, and under that we have various feeds. Now each feed is allocated to the floor of the Davis Hall. So for example, this HUM and TEMP is associated to the first floor of Davis Hall. Likewise for HUM2, TEMP2, HUM3, and TEMP3. And this luminosity feed is basically for the photocell that is on the ground floor. And here we have the MQTT test 2, which has this motion feed, which basically allows us to monitor the motion, if there is any, in the vicinity of the unit, which is at the ground floor. Now for our project, we are also using the IFT platform. It basically allows us to make our unit more smarter. So you can see we have a statement set up here: if data on MQTT test, which is the temperature feed, is greater to 25 degrees Celsius, then send an email to this email ID, hence notifying the user that we need to do certain actions, which we will eventually show in our final demonstration. So these are the two main platforms, Adafruit IO and IFT integration with the IO.
So the Arduino Maker Wi-Fi boards act as the MQTT clients, which communicates with Adafruit IO. So anytime this sensor reads, after it reads the temperature and humidity change, every 20 seconds, it sends that data over to Adafruit IO. Same thing with luminosity, when every 20 seconds, it sends new data over to Adafruit IO. These boards are running similar code to the two ESP32s that are in the two floors above. So here we can see there's 3 sets of values for each floor. This is the first floor, that's temperature, humidity, and luminosity, because the first floor is the one that has the luminosity sensor. And then for the second and the third floors, we just have temperature and humidity. Now all 3 of these values are being updated every 20 seconds, with the maker boards being updated every 30 seconds. So you can see for the temperature second floor, this graph represents the temperature over time, and you can see the different values that were given every 20 seconds. So Mohammed is currently heating up the temperature sensor by applying a lighter next to it, and the temperature value that it's currently reading is 23 degrees for the first floor. So once that reaches 25 degrees in due time, it'll send an email to his Buffalo email that notifies him that the temperature has gone above 25 degrees Celsius. So you can see that the temperature gauge currently reached 25 degrees. So he should get an email shortly that notifies him that the temperature has gone above 25 degrees. So here we can see the temperature value went up to 25 degrees, which prompted an email to his Buffalo email from the IFT platform.
So you can see here different readings of different floors. So our sensors seem to be operating fine, and our Arduino is getting all the data, and this data is being fed to the cloud. So the system appears to be working fine. You can see that how the temperature varies as we go up the floors, and also for the humidity. We are also measuring the luminosity value, which keeps on changing. So everything is incrementing after 30 seconds. So just to conclude, the overall idea for this project was to come up with a smart system which basically was designed to monitor the parameters of Davis Hall. So we had two ESP32s which were talking to each other using ESP Now, and we also had two maker boards which were integrated separately to the cloud. And the cloud that we were using in this case was Adafruit IO, and we were also using the IFT platform to make our system more smarter and get the notifications in case there was any deviation in the temperature, in our case, for example. So thank you so much for your time, and if you have any questions, you can always ask us. Thank you.